In this video, we want to look at hybridization of all the atoms in our molecule and how they overlap to start making bonds between our atoms. So this is fundamental for how organic chemistry molecules are made. Let's jump right in. We've seen that our carbon atom has s orbitals and p orbitals. And the p orbitals point in different directions. And not only our carbon atoms, but oxygen, nitrogen, any atom that's bigger than hydrogen, let's say, the second, third, fourth rows, they have s and p orbitals in their outermost shell, the valence shell. And we saw in our last video that these s and p orbitals can overlap in different ways on an atom. We call that hybridization. So our carbon atom has maybe a 2s orbital and 3 2p orbitals. I want you just to remember that these are all on the same carbon atom. So these can mix together in different ways on that carbon atom to make orbitals that we call sp, sp2, and sp3. And once again, it depends on how many of these s and p orbitals we mix together. So if we mix one s and one p, we get sp hybrid orbitals. If we mix an s with two of the p's, we get sp2 hybrid orbitals. And if we mix the s with all three p's, we make an sp3 hybrid orbital. And depending on how many orbitals we mix together, one s and one p, that makes two of these sp hybrid orbitals. Or if we mix one s and two of the p's, 3 total orbitals, we make 3 of these. And if we mix one s with 3 p's, we make 4 of these. So let's take a look at what the shapes are of these orbitals. When we get 2 sp hybrid orbitals, let's mix them together with orange. We get 2 lobes. One of the sp hybrid orbitals points one way and one points the other way. These electron clouds get as far away from each other as they can. So this might be on one carbon atom. And if I mix, so I'm always mixing an s in my p orbitals. If I mix one of the s's with one of the p's, I have 2 p orbitals left over that I didn't mix in. So let's draw those in there too. So this carbon, if I just mixed one of these and one of these, I have these 2 left over. So I'll draw those in green because I have 2 p orbitals that I didn't mix in. And similarly, in the case of the sp2 on a carbon atom, I would make 3 sp2 hybrid orbitals. And those will get as far away from each other as they can, so they're about 120 degrees apart from each other. sp2, 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 3 of them. And they're this oblong shape. Now if I mix an s with only 2 of the p's, I would have 1 p orbital left over that didn't mix in. And again, it would still be green because I didn't mix it with anything. And it would point, in this case, in and out of the piece of paper. If I mix all 4 of them together on my carbon atom, I get 4 lobes of sp3 hybrid orbitals. And they would form a tetrahedral kind of shape. And each of these is an sp3. And if I mix an s with all 3 p's, of course, since I mixed them all in, there are no green unhybridized p orbitals left. I've used them all up, mixing them or hybridizing them into my 4 lobes. So if I need 2 things on my carbon atom, I'm going to mix as sp. If I need 3 things, 3 atoms or lone pairs, we'll mix it as sp2. And if I have 4 atoms or lone pairs, I'll mix it as sp3. So let's take a look at one molecule and see how all of the bonding occurs. So let's draw something like this. Let's take an oxygen, double bonded to a carbon. Let's put a hydrogen on it. Maybe a CH2 and a C triple bond to a nitrogen. I'll draw in my lone pairs of electrons for normal bonding patterns. And let's see if we can draw out all of the orbitals of all of the atoms and see how they would overlap to start to stick together to make bonds. So the first thing I want to do is let's go in and see what we think the hybridization would be for all of the non-hydrogen atoms. For the hydrogens, of course, they only have one electron, so they're just 1s orbitals. They can't mix with any p's because there's not enough electrons. They don't have p orbitals to mix with. But all of the other non-hydrogen atoms, the oxygen, the carbon, the nitrogen, they can hybridize and mix the orbitals on the atoms. So let's see what we think the hybridization should be for each of these. Let's start with this oxygen. Well, we see on the oxygen, it has a carbon atom, so one atom. It's got a lone pair of electrons and a lone pair of electrons. So 1, 2, 3 things we're going to mix together. So I need 3 things, so that will be an sp2 hybridized oxygen. It'll have 3 of those sp2 lobes on it. This carbon has a hydrogen, a carbon, and an oxygen, and 0 lone pairs. So this is also sp2, 3 things. This carbon atom has carbon, carbon, hydrogen, hydrogen, 4 things on it. So it will be sp3 hybridized. I have to mix all of those. This carbon has a carbon, a nitrogen, 0 lone pairs. So I need 2 lobes. So it will be sp hybridized. And this nitrogen has a carbon atom and this invisible lone pair of electrons. So it will have 1, 2 things on it. It's also sp hybridized. Okay, so let's start to put all of our atoms together. So let's draw all the hybrid orbitals and the bonding up here. So I have an oxygen, I have a carbon, I have a hydrogen, I have a carbon, a couple of hydrogens, a carbon, and a nitrogen. So let's start to draw in our orbitals. So we'll start with our hydrogen 1s orbitals. There's no mixing, they're still spheres. But for the oxygen, we said it was sp2 hybridized. So we're going to draw 3 sp2 orbitals. One will point towards this carbon. They'll be 120 degrees away from each other. These are the sp2. Let's see, what color should I write? Can I write that small enough? sp2 orbitals. There's 3 of those. And this carbon atom we said was sp2. So one of those sp2s will point this way. One will point towards this carbon and one will point towards that hydrogen. These are also sp2 on that carbon right here. Let's see, our hydrogen 1s orbital is still there. These are all 1s. This carbon right here is sp3, so I need 4 lobes. One will point towards that hydrogen, one towards this one towards that carbon, and one towards this carbon. So let's see if I can sp3 for all of those. And this carbon needed 2 things, so it's an sp. One of those, so I'm going to draw 2 of them. One points towards that carbon, one points towards that nitrogen. sp and sp. And the nitrogen atom we said was sp, so one points towards that carbon, one points on the other side. sp, sp. Let's go back and look at our lone pairs of electrons. So let's take these 2 pairs on the oxygen. Well, those must be in these sp2 hybrid orbitals. They'll just be big blob of sp2 hybrid orbitals for 2 electrons there and 2 electrons there. And then these 2 electrons are in this sp hybrid orbital. Now let's look at some of these atoms are now connected together. We have right here between carbon and hydrogen, this sp2 overlapped with that hydrogen atom. Between oxygen and carbon, we have 2 sp2s that overlapped to make a bond. Between this carbon and hydrogen, an sp3 overlapped with that hydrogen, and an sp3 overlapped with that hydrogen. Between these 2 carbons, an sp3 and an sp overlapped to make a bond. And between these 2, an sp overlapped with an sp to make a bond. So all of these bonds that are directly between these two atoms we call sigma bonds. So all of these spots are sigma bonds, the ones that are directly between two atoms. And there's one more sigma bond right there. So that's this first bond that we stick between them are called sigma bonds. So that's where all the single bonds or sigma bonds are. But we also have a second bond here and a second and a third bond here. And right now I only have one bond between carbon and oxygen and only one bond between carbon and nitrogen. So where do those other bonds come from? Well, those bonds come from these green unhybridized p orbitals that were left over. I forgot to draw those in over here. So let's go back and look at this oxygen atom. We said it was sp2, and I drew the 3 orange sp2 hybrid orbitals, but I forgot this green p orbital that was left over. And this carbon atom we said was sp2, so I have 3 orange sp2 orbitals. But I forgot to leave the p orbital that was left over that I did not mix in. And what happens is these p orbitals, these electron clouds overlap and these electron clouds overlap. And above and below that carbon and oxygen right now, we make a second bond. And we call that kind of bond a pi bond. So sigma bonds go directly between the two atoms and pi bonds go above and below. So inside of this, I have a sigma bond, and let's make the pi bond a different color, maybe purple, and a pi bond. So there's the pi bond. So I have a sigma and a pi that make that double bond. This will be a sigma, this is a sigma, 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 and I have one sigma there. Now the other two bonds for these, I have to draw in my unhybridized p orbitals again. So this carbon atom we said was sp hybridized. So it needs to look like this. I only mixed one s and one p. So I had 2 p orbitals left over on this carbon. P orbital, p orbital. And on this nitrogen, it's sp hybridized. So I forgot my 2 p orbitals. And then these p orbitals, one of them can overlap and the other one can overlap. So that means the 1 p orbitals that are like this, they overlap to make a pi bond. The other p orbitals are sideways, and they'll overlap like this and make a sideways p orbital. So you have one that's vertical and one that's horizontal, and I make 2 pi bonds that way. So 1 and 2 different pi bonds. So in this triple bond, the first one directly between the carbon and nitrogen is called a sigma, and the other 2 are pi bonds. So always, the first bond between two things is the sigma bond, the one that's directly between them. If you have a second bond, it'll be a pi bond. It has to be on the outside. And if you have a triple bond, you'll have one pi bond, and then you'll have another pi bond that's turned 90 degrees to that. So that's the bonding of how things are put together. So let's just pick one more molecule real quick. Pick a better color. And let's just determine what our sigma and pi bond contributions look like. So if we go through, I have a sigma bond. I'll make those green. I have a sigma bond here, one here, one here, one here, one here. So there's one sigma bond that's between all of them. Now if I have a second bond, we'll make that one purple. It needs to be a pi bond. So all of these others are sigmas. So I have a sigma and a pi, one sigma and pi there, one sigma, one pi here. So sigma and pi, sigma and pi. And then between these two carbon atoms, I have a sigma, and everything else has to be a pi. So the sigma between these two carbons, a pi this way and a pi that way, holding them together. So that's my triple bond. So I have a sigma, a pi, and a pi. Here I have a sigma and a pi. Here I have a sigma and a pi. Everything else, all these other single bonds are sigma bonds. So I hope that makes sense. Now, granted, this is tough sometimes the first time through. This video might have made sense, but then all of a sudden, 3 days from now, you'll forget everything about it. So you need to review your textbook, maybe rewatch this video a couple of times. But soon, the words like sigma and pi bonds will become second nature. The hybridization of an atom becomes second nature. It's okay if it doesn't click the first or second time through. Sometimes it takes us 3 or 4 times to see something before we're like, okay, now I finally get it. Hey, if you could, subscribe to the channel so you get to see all of my organic chemistry videos so I can help coach you through your organic chemistry journey.